Here we go. We're finishing it up strong. Always finish strong. We're going to do DEF of this investigative task. Now, I took it off my clipboard here because I do have to flip back and forth. Remembering that method 1, it's either going to look like this or that. Method 2, I'm going to be picking stuff from all over, and they actually did us a favor and they gave us an example of what method 2 could look like. I'm going to write that really big. Method 2. Okay. Now they're asking very specific questions about this. So let's do it. It says each day the distribution is 200,000 and the mean is 6. So this is of all. So they took the mean of all the chips, and that's 6. And that makes sense. We already calculated. We think all the chips should be 6 if we're doing all the chips that the factory makes, all 200,000. Okay. So they said all 200,000 have a mean of 6 and a standard deviation of 0.11 inches. For sample size of 200 taken from 1 day's production, describe the sampling distribution. So anytime they ask you to describe a distribution, you're going to cuss and BS. Goody goody. So the center is 6. The standard deviation of this sample, right, because mu x bar is 6. And the standard deviation of my sample is sigma over the square root of n. That's right out of my formula sheet. So sigma is 0.11 over the square root of 200. And so I just need my little calculator here, and I get 0.0078. So notice when I take a big sample, variability goes way down. So if I'm really going to take a sample of 200, then using method 1, oh my gosh, and I just flip-flopped it because it's too late at night. Method 2 says you're going to select one production line at random. So this definitely has to be method 1. Method 1, okay. Method 1 is when, that's exactly what I said, method 1. Method 2 is when you pick one line at random. Method 2, one line at random. Okay, sorry about that. Now I got my wires straight. Now it says, if this was the sample size, describe the sampling distribution of method 1. So if we take samplings like this over and over and over again, we're actually going to get a mu of 6, and that should make sense. All of these, taking an average of these averages, are going to converge on 6 and have a very low standard deviation because it's the average of the averages. So again, as long as anytime you do a sampling distribution, it's going to be approximately normal. And that's me describing the shape. So I describe the shape, approximately normal, the spread, the center, and there's no outliers. It didn't come up, so I'm not going to mention it. Now, E. E states, suppose that one of the sampling methods are going to be selected and used every single day for 365 years. So instead of doing either method 1 or 2, you're going to just select one of the methods. The sample mean of 200 will be recorded each and every day. Which of the two methods is going to result in the less variability? Now, this is going to take some thought because my answer here is definitely method 1. So if I look up here at method 1, it doesn't look like low variability. So it feels like I'm doing the opposite of what I just got done saying here. Method 2, if I'm just doing a sample one day of 200, method 2 would result in less variability because method 2 would either look like this or it would look like that, and therefore it would not be as wide. But if you repeat this over many, 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 many days, and that's what they've changed here, the repeated samples. And that's this idea, not of a sample distribution, which is what this is, but a sampling distribution. So suppose that either method is chosen, which one's less variable? Method 1 is less variable. And the reason why is that method 1 is going to converge on 6.0. Method 1 is less variable in the sample mean over the 365 days, because with method 2, remember, roughly half of your samples, or whatever half of 360 is, roughly half of those samples will be around 5.9, because again, method 1, either the center is going to be around 5.9 or around 6.1, depending on which production line was chosen. And again, if you repeat it over 365 days, there's going to be an equal chance, and you should have pretty much half the time you use production A and half the time you do production B. Just like if you flip a coin 365 times, it's pretty much going to converge on half of the time heads, half the time tails. And so for that same reason, the sample mean will be around 5.9 or 6.1. Well, actually 5.9 and 6.1. Depending on which production line was used that day. Okay, and so each of those samples, you can think of dots. This one, the dot goes to the left, that dot goes to the right. Left, right, left, right, left, right, left, right, left, right, left, right. That's what's happening in method 2. Whereas method 1 is just averaging up all these and getting one number that's the average. So let's say that in a sentence. Let me pin down my paper here. It keeps scooting around on me. Method 1, however, the sample means will all be very close to 6 inches, as indicated in this standard deviation here. All right, last little part. Let's try to squeak out one little bit of partial credit. F says a government inspector is going to visit the facility on June 22nd to observe the samples and determine if the factory is in compliance with their advertising. The manager knows with both sampling methods that the sample mean is an unbiased estimator of the population mean. However, the manager is unsure which method would be more likely to produce a sample mean that's close to 6 inches on the day that the inspector's there. Based on your previous answers, which of the two sample methods is more likely to produce a sample mean close to 6? Well, that's what we just said. We just got done saying method 1 is, and I'm repeating the sentence, more likely to produce a sample mean close to 6 inches. And that's what we want to have happen when the inspector gets there. So let's think about that for a minute. If we pick method 2, if we end up picking method 2, we may end up getting under 6, and that's disastrous. So we're taking a 50-50 chance that we might get too small a chips. We're also taking a 50-50 chance that we're gonna overshoot, which we like that, but not with a 50-50 chance. Here, we know during sampling that since the means through transformation will converge on 6, then that is the most likely outcome because that's the highest part of the peak, which means the most likely outcome. So let's finish this out. Method 1 is more likely to produce a sample mean close to 6 because my paper's moving. I can't finish strong if my paper's wiggling. Because the sample mean is an unbiased, just like the question said, an unbiased estimator for both methods. So therefore, it's fair for the company to use both methods. So therefore, it should be up to the manager to decide, and the manager should pick the method that would result in the best outcome. And notice, if I picked method 2, I'd likely have a low chip outcome, and that would be disastrous. Thank you for joining us. I can't wait to congratulate you guys on graduation day and or the end of the school year. Be safe.